So this is going to be pretty much a continuation from where we left off. Um, I was talking about the generics and what was the other thing? Interfaces, right? How we can have polymorphic implementation of data access object. So that was actually a good example of that. And yeah, so I got to show you where you can use interfaces and how you can have polymorphic behavior. But the first thing that I introduced in there is that I said you can have generic types so that you can just create a single interface and then have multiple implementation of it without declaring new interfaces. Now, in order to show this idea, what we did before is that we had this student data access object, and from there we have two different implementations, one for file and another one for databases, right? What if we have other data types that we want to store into our database or into our file? So what about a course or a faculty or anything as such, right? Let me share my screen and let us build on from there. So what I want to bring out is this thing that what we have for student DAO is going to be pretty much the same for the course DAO, not with a big O like that. Okay. So for student DAO, we got find all and find by ID, and it's pretty much the same thing we will have for course DAO. So to start with, what I would like to do is I would do exactly the same thing. I will create a course DAO. So let us go ahead and create this course DAO. And there, the methods that we are going to add, let me steal them from here. And you'd see why it is becoming so worthless, or redundant rather, that here we are only dealing with course, and we are going to return a course. Now we do have a problem here because we don't have the course type defined. It's an easy fix. So if we were to create a course data type, let me create a very simple one where we have a private string code and private string title to keep it simple. And we can bring out the constructors and the getters and the toString, right? So let's have a constructor. Let us also have all the getters, and finally a toString. So it's nothing fancy, but it's pretty much a functional class. Okay. Now, as we had the student DAO file implementation, we can do something very similar for this course DAO. So to save time, why not I just copy paste this? So I did Control C, Control V, and now we can do course DAO file implementation like this. It's just that it's going to have all these things that deals with students, right? So one quick fix for that can be, why not let's do search and replace. So wherever we see student, we replace that with course, but at the same time, we got to make sure that don't we have this option that preserve case? Yeah. Okay, they have changed these things with icons, and that confused me. So in this new release of IntelliJ IDEA, previously we had like text with checkboxes. Now we don't have that. Either way, it's the same thing. So we changed that in so many places. And implements course DAO, which is going to be fine. It's just that course DAO has to be an interface. So mistakenly, I didn't notice this before. I left it as a class. So now no more complaints. We got the file name, and previously it was students.txt. Now it's courses.txt. And everything else, since we did a search and replace, they got updated. However, a few things should change. So instead of having a long ID, we don't have that. We have a code for each of the courses, and a course can be created out of the code and the name. It's not really called a name though. What's that? Shift F6. So we're going to use title. Shift F6 is, by the way, for renaming. And once we're done with this, we return the course list. And for find by ID, we're not finding a course by a long ID, right? Because the courses, they can be looked up with the course code, which is a string. So course.getCode, I suppose. If it is equal to the code, then we can return the course, otherwise we can't. Now, since we are comparing two strings, they cannot be compared with the equal operator, right? You have to use the dot equals, this method, and within that you pass the code, the other string. So if there is a match, we return the course, we found the copy, otherwise we return null. So it's a very simple implementation that we could manage to do just by implementing this course DAO. So find by ID, well, it looks for ID by long ID because I didn't update this. This was supposed to be string. And rather than saying ID, let's just say code. Although the find by ID, I'd keep the name because I want to have the same names here. So this is a quick and simple example where we could create a new interface and then have an implementation for that. Just a bit. Okay, sorry about that distraction. So yeah, it should work. Let's say we create a test for this. So just like we have a student DAO test, we can copy paste this to save time. We can say this is going to be our course DAO test, right? So we can add that to the Git repository, and I don't want to have the MySQL implementation because we don't have one. We only have, excuse me, the file implementation here. And I want to do something very similar. Everywhere you find student, replace them with course. That saves time. Okay, so we have the test already. And the other thing that I want to do here is I want to create a file, a text file called courses.txt. So within this file, I'm going to create all the courses, just like we have our courses. So CSE2015, this one, the title is Programming Language 2 Java. And then we can have CSE2016, which is pretty much the same thing, it's the lab course. And let's say there is another course, Math 1024, which is, what was that? Coordinate geometry, right? So it's just a list of 3 courses. Nothing much, but yeah, we got all of them. So the MySQL implementation is not there, and it was complaining because we had that import. So at this point, if we run the course DAO test, everything should work. like we should have a list of 3 courses. Okay, and it was fairly simple. So we had to create a new interface for course, the course DAO, just like we had one for student DAO. And you can imagine for every other data type that we have that needs persistence, that needs saving into the database or into a file, or to be read from a file or a database, we will have to create new interfaces every single time. And at some point you'd get bored of it, and you'd see that there is no real purpose in it. So rather than doing it in that fashion, why not we create a generic interface which can be used for anything really. So the way we do that is let's just create this with a name called CRUD DAO. So we're going to have all the CRUD facilities, create, read, update, and delete, all these things within this DAO, okay? But we need to give support for all these different types. Now, if it were for a student, I mean, we know exactly how it looks like. So let me copy it from here. But within the CRUD DAO, the problem is, since it's going to support everything, we can't just write student in here. Okay, it can be student, it can be course, it can be faculty, you name it, whatever type it is, it's going to have that thing. So instead of saying this, why not give it a generic type? And to represent that, we're just saying the type is represented by T, where T can sometimes be student, or it can be a course, it can be anything, right? So that's what T represents. And this is not really entirely new to us, because we've been using array lists like this. We say what data type we'll be using for that array list, and elements of only that particular data type will be added there. The other thing we need to change in here is that sometimes we see that for a student, the ID is of long type, but for a course, the ID is not long, it's actually a string. So this can also change, right? So instead of typing long, what if we can give it a different name? Okay, so let's just use S to represent that idea. Now, in order to have this as a generic, all we need to do is we got to say that we have to mention the type, and we have to mention the type of the ID. So within the angular brackets, this is what we supply. Okay. So if we have more types that are different, like we have 2 different things to deal with. One is the data type of the object that we're going to store, and the other thing is what's the data type of the ID. Since we have 2 different data types, we had to put them in comma separated list in angular brackets. That's how we mention the generic types. Now, when it comes to the implementations, the actual implementations, this is where the fun stuff begins. If you look at the course DAO file implementation, it implements course DAO. But we want to get rid of that course DAO. We don't want to write it again, because we are doing this for student, we're doing this for course, we're doing this for faculty, and it is really worthless. So instead of doing that, what if we could use this CRUD DAO? Okay, now it is complaining because we don't have anything that says that the data type we're representing here is course, and the ID for course is a string. We're not saying that anywhere. Now, this is where we need to supply that we are doing this for course, and the ID field for each course is a string. So as soon as you do that, everything works just fine. Okay. So for student DAO implementations, wherever we have it, instead of having student DAO, why not we write CRUD DAO of student, and the data type here for the ID field is long. Okay. Okay, so yeah, here we got a little bit of a problem. This should be long like that. We should use the class, not the primitive type, and that's the only problem we had in here. For the MySQL implementation, it's pretty much the same thing. What we need to do here is, instead of saying student DAO. What if we could say CRUD DAO? And yeah, the same thing, student and long. And we need to fix this one down here for the ID. And that's pretty much it. So what I'm trying to say here is that the student DAO and the course DAO, they're no longer needed. We can have a common interface, which is parameterized, which is using generics. And these parameters, by the way, this is what is the basis of generics. You write code in such a way that it can be used for all these different types. And that's what makes it generic, in a sense that it is generalized. It can be used for anything and everything. So finally, when we have the course student DAO test or the CRUD DAO test, you can't really use this anymore. Because the student DAO, it doesn't exist here. So we are going to use CRUD DAO. This is where we can say that this is going to be for student. And for student, the ID is long. And see, now this works, no more complaints. For the course DAO, the test, again, course DAO doesn't exist. If we have CRUD DAO, we can say that this is going to be about course, and the ID for a course is a string. So at this point, if we want to run all the tests, you can do that for any given package, and it's going to go through each and every class, run all the test methods in one go. So it's quite convenient to do it in that way. And what we will see is that for the student DAO, since we're using CRUD DAO, we don't need that anymore, but the idea still prevails. We are using a MySQL implementation for the student one, and we are using a file-based data access for the CRUD one, the course one rather. So yeah, we're reading this from a file, but if you look at the student, these are actually read from a file, yeah. But that's the reader test. This one rather, this is read from a database. So even that works. So whatever you want to do, it's really very simple. You can use the generic data types, and over time, as you gain maturity, you will learn where to use the generics and how to use them in a right way. So the thing that I would argue over here is that rather than creating multiple interfaces for the same reason, we should be able to reuse our code. Okay, and this is where the generics come into play. So yeah, that was pretty much it. That I got to show you how you can include generics in your definition, the interface definition, and that way you have to write less code, and you can make sure that your code can work for any given data type. Like you can just imagine that in Java, we have a really useful class called ArrayList. But if the Java people had to write ArrayList class, a different one for string, a different one for integer, another one for perhaps our bank account, which wasn't even possible because they don't even have a bank account data type in Java library. So when you design interfaces or classes with generics, you make it future-proof so that people can use it later on with their own data type. And that's a really good benefit of having a powerful tool like this, okay? So with that, I'm going to wrap this up. This is the second part of this thing where I wanted to cover generics. And previously I did talk about polymorphism. And both these things, the idea I think is fairly simple, but to understand where to apply them and how to use them really, it takes quite a bit of maturity. So don't get lost or don't feel lost if you don't get it in the first go or don't really understand where to use it. It will come with time, okay? So with that, let me conclude this session. In the next session, I think I will be covering multi-threading, which is another very important concept for a lot of your courses, okay? So till then, bye. Oh, I forgot. This is Eid Mubarak to you in advance. There won't be any recording tomorrow. So have a nice Eid and have fun in a limited scope, right? So it's our Shinito Porishore Eid Mubarak. Bye.